Okay, now let's begin our second lecture for the chapter 2. And first, we will get a little introduction of what we studied in the previous lecture, then we'll continue with our current lecture. And this lecture, these topics are easier, so we will quickly go through them. So basically, this is the chapter name is data transmission. It means in this chapter, we study how data is transmitted between devices, and data is basically converted into small data packets, and they could be of size 64 bits for each packet. Basically, data is divided, broken into small packets, and this is how we transmit the data over the internet or over the between devices. Now there are data transmission modes. First data transmission mode is simplex. Simplex transmission modes in which data transmission occurs in one direction. For example, we have we can only sender can send to the send data to the receiver, but receiver cannot send data back to the sender. So an example of this would be sending data from a computer to a printer, and because printer does not give the command back to the computer. Or the most common example is radio transmission or television transmission. Those are examples of simplex data communication. Half-duplex data transmission is half-duplex mode occurs when data is sent in both directions but not at the same time. For example, when we have if we use the walkie-talkie, when walkie-talkie, one person is speaking, the other person is silent at that time, and then when one person takes it and hand off the button, then the other person starts speaking, his voice starts coming. Where a message can be sent in one direction only at a time, but the messages cannot can be both received and can be both received and sent, but not at the same time. And let me give you another example of half duplex. That is basically our ATM machine. That too is an example of half duplex. For example, you insert the card machine. Once your card is received, then machine responds to you, and then it asks you to enter the pin number, and when you enter the pin number, only then it gives you the cash back. Means one sender's conversation should be completed before the other device starts to respond. Okay, next is full duplex. Full duplex is a two-way communication. Both devices can send and receive data at the same time. Example is telephone calls, you can say. Now the next is let's see the characteristics of simple data flows in only one direction. It's the repetition, no return channel for feedback or acknowledgement. Example, TV broadcasting. Advantages: it is cost effective and simple, easy to implement due to one-way communication. Disadvantages: no error correction or acknowledgement, inefficient for two-way communication needs. Half duplex is data flows in both directions but at different times. Shared communication channel for both sending and receiving means sender and receiver both share the same channel for the communication. Walkie talkies, and the benefit is more efficient than simplex as two-way communication is possible, cheaper than full duplex systems. And disadvantage is slower than full duplex since only one direction can transmit at a time. Possible delays due to switching directions. Okay. And next is the characteristics of full duplex. Data flows in both directions, requires two separate channels or frequencies, and telephone calls is the examples, and the fast and efficient as both parties can communicate, both devices can communicate at the same time. Ideal for real-time application means where we need quick responses. Disadvantages: requires more complex hardware, more expensive than half duplex. Now there is another kind of transmission that is called serial transmission. In serial transmission, is data transmitted. This data transmission occurs when data is sent bit by bit over a single wire channel. Bits are sent one after the other. We cannot send multiple bits at the same time, or one second bit will be transferred after the first bit. So bits are sent in one after the other. Okay, and serial data transmission works well over long distances. Slower data uh, okay, serial. Okay, it is slower, but the data arrives at its destination fully synchronized. Okay, and connecting a computer to a printer via USB connection, that is basically serial data transmission. Next is parallel data transmission occurs when several bits are transmitted at the same time. For its examples, we will see the examples. Parallel data transmission works well over short distances, and the internal circuits in a computer use parallel transmission. For example, between hard disk to RAM data transmission, between there we use parallel data transmission. It has faster speed, but over long distances data can become skewed. This is not suitable for long distance communication at all, because data may become skewed and bits can arrive out of order. Next is serial, and now let's see the comparison of serial and parallel data transmission. Risk of uh, external interference due to fewer wires and faster rate. Okay, let me just let me give you a picture of what serial data transmission is. Suppose this is our line, and this is our wire, and over this wire, these are our bits that are transmitting. Some bits will be definitely 0, some bits will be 1. Suppose this is 0, this is 1, then again 0, 1, 0. So this is kind of serial. This bit is transmitted, then the second bit will be transmitted after it. Whereas in parallel data transmission, it inside the computer components, suppose these are two different components, hard disk and RAM. So they are basically connected via data pass. So how is it happening? The data is transmitting between them. This is 1 bit, this is 0 bit. So one one or whatever we can say. All of the bits are transmitting together at the same time. So this is why parallel is faster, because all bits are transmitting at the same time. Is in this, one bit has to transfer after the other. Less risk of external interference due to fewer wires, because wires are fewer, so this is why external interference chances are low. Faster rate of data transmission than serial, more reliable transmission over long distances. Serial is more reliable, and parallel is for short distances. Now, transmitted bits won't have the risk of being skewed, because skewed, by skewed it means that uh, they will not uh, they will not disperse. They will transmit in the right order. But in the parallel, bits transmission can be can get skewed, and that their order may differ. Bits can arrive out of synchronization, means bits can arrive out of order. Used if the amount of data being sent is relatively small, and preferred method when speed is important. Okay, you serial is used to send data over long distances. If data is time sensitive, parallel is the most appropriate transmission method. Uh, Parallel is for time sensitive, and this is for distance sensitive over long distances. Less expensive due to fewer hardware requirements. Serial is less expensive. Parallel is very expensive, requires a very complex hardware, making them more expensive than serial, and easier to program input output operations in parallel. Serial data transmission applications. USB devices are serial data transmission, long distance communication. If you can call in telephone networks, we use serial and fiber optics. Internet communication data packets are transmitted serially, and satellite communication transmitted signals to and from satellites over large distances. And parallel transmission is basically between internal components of the computer, CPU, memory, buses, internet, and printers. Parallel ports, Centronics interface are used in older printers for faster data transmission. Basically, printer used to have uh, this system as well. And then integrated circuits, ICs, communication between chips and microprocessor. Electronic systems often use parallel transmission. High-speed devices, SSDs, use this parallel transmission. High speed and simple error detection. This is why we use parallel data transmission. Disadvantage is signal skewed, bits traveling through different channels, and costly and complex, limited to short distances. means signal can degrade it and we cannot increase it for the long distances, use it for the long. Now, whereas serial can be used for the long distances, cost effective, reliable for long distances because it doesn't skew the data, and uh, less interference, reduced crosstalk and electromagnetic interference due to fewer wires. As wires are fewer, so this is why very low chance of electromagnetic interference. Slower for short distances and complex timing means requires precise timing mechanism, especially for synchronous communication. So let's see this difference again. Number of channels. These are the things that are different in the parallel and serial. Number of channels. Parallel has multiple channels. Serial has single channel. Transmission speed. Parallel is faster, efficient for long distances. Serial, but it is slower. And cost is more expensive. Parallel is very expensive. Cost effective is serial. And complexity more complex is parallel, and simple is serial. Distance suitability limited to short distances is for parallel and ideal for long distances, that's serial. And error handling prone to synchronization errors can occur in parallel and less prone to errors, that is serial. Now let's see these questions, and our concept will be way more clear than other. Let's say explanation of data transmission types. The first type is serial transmission. Serial and half duplex transmission. What will be the serial and half duplex transmission? Basically, data is sent one bit at a time, but only in one direction at a time. Either send or receive, not both simultaneously. Is sent one bit at a time, but data is sent one bit at a time. That is a part of explaining this serial. And whereas, okay, let me end this thing. Okay, data is sent one bit at a time. That's serial. And half duplex is but only in one direction at a time. What is parallel data? Parallel and full duplex data, multiple bits can be sent at a time. That is parallel. Full duplex means both devices. It can be transmitted between both in both directions. Next is serial and simplex data, one bits at a time, but uh, it is. But data is travels in only one direction, not in the both directions. Types of data transmission described. Let's say one bit at a time, one direction, and parallel is 8 bits at a time, one direction. That is parallel. Basically, these are the answers given. Parallel, half duplex are the answers given for these questions. One bit at a time and one direction. One bit at a time means it's serial. One direction means one bit at a time is serial. One direction means it's uh, simplex. 8 bits at a time parallel, one direction means simplex. Then 16 bits at a time means it's parallel, both directions, uh, both direction means half duplex. Okay, it hasn't mentioned simultaneously, that's why we are calling it half duplex. One bit at a time, that is serial, and both directions simultaneously, that means full duplex. 16 bits at a time, it's parallel, one direction means it's simplex. Packets have a header which contains IP address of the sender and the receiver. Packets include, let's say, these are the basically questions for activity 2.3. Packets include, packets have a header. Every data packet has three things. Number one is header, number two is payload, number three is trailer. So what this question is saying, packets have a header. Header contains the IP address of the sender and the receiver. That is true because every packet has the header section that contains both IP address and the IP address of sender and receiver both. Packets don't require any form of error checking. That is false because packets do require error checking like CRC, and we put that in the our trailer because packet has that part as well. USBs use a protocol that allows for free data transmission between device and computer. USBs use a protocol that allows for error-free data transmission between device and computer. Basically, USBs use a protocol that allows for error-free data transmission. Let's see it. Yes, of course, it's true. because USB has that mechanism. Because the USB also transmits data to the device, so this is why it is true. Serial data transmission suffers from data skewing. No, it's false. Serial data transmission does not only the because it sends bits in the sequence, which eliminates the risk of data skewing. The longest cable length supported by USB is 5 meters or less. True. For standard USB cables, the recommended maximum length is 5 meters. Now, the simplex data transmission occurs when data is transmitted one bit at a time. Well, let's see. No, simplex occurs when the data is in one direction. Simplex is related to the direction. Serial is basically the one bit at a time. Now, next is full duplex data transmission involves sending 8 bits of data at a time. Full duplex, no, not necessary. Full duplex can be serial as well. So that is basically parallel it is talking about. So this is false. Now, if you talk about USB uses serial data transfer, absolutely true, meaning data is sent bit by bit along a single channel. Packet switching prevents loss of any data packets. Wait, packet switching does not prevent itself. We require we have to set our packets by using hop number, CRC error checking, and there are different methods to end this part. Lost packets can be retransmitted. It depends on the basically protocol. Packet switching doesn't prevent data loss for more efficient use of network. USB connections can transfer data using half duplex or full duplex. That is true. USB connections can support both half duplex and full duplex modes. Explain what is meant by serial half duplex transmission. We have already done that. Serial half duplex is data is sent bit by bit over a single channel or wire. Half duplex means data travel in both directions, like walkie-talkie. And parallel means multiple bits are sent simultaneously over multiple wires. And full duplex data can travel in both directions at the same time. Example: high-speed internal connections in a computer, like RAM, CPU, or SSD. Serial simplex data is sent one bit at a time over a single channel. Simplex means data flows in one direction. Let's see the example. Computer sending data to a printer, and let's see which type of data transmission are being described. Data is sent one bit at a time in one direction only. One bit at a time. Serial and simplex data is being sent 8 bits at a time in one direction only. That is parallel and simplex. And data is being sent 16 bits at a time and in both directions simultaneously. One is parallel and full duplex. Data is sent one bit at a time in both directions, serial and full duplex. Data is sent 16 bits at a time in one direction only, parallel and simplex. That's it. See, that is how it's going. Now let's talk about the USB. USB is the standard for data transmission between computers and peripheral devices. Basically, we use USB cable to connect keyboards. We use USB cable to connect mouse and even Wi-Fi cards. So we use a lot for this for a lot of purpose. So serial transmission. USB uses serial transmission, meaning data is sent one bit at a time along a single channel. Common usage. It is widely used for connecting devices like keyboard. Standardization. USB has standardized way of communicate with computers. Uh, has basically USB has standardized the way to communicate with the computer, making it universally compatible across all platforms. As almost all computers have the USB cable, though nowadays Type C is trying to take over, but so still the USB cable is used a lot. Half duplex data flows in one direction, that is half duplex data. These are data transmission modes we have already studied, and half duplex and full duplex. These are data transmission modes for USB, sending data to a printer and reading and writing data on a flash drive. So this is basically the construction of a USB cable. It has red wire that is of plus 5 volts, white wire that is data positive, and the green that data is negative. negative, and black is the ground wire. So the USB cable consists of four wire shielded cable: red, white, green, blue. RGB you already know, and other is the white. The other two wires are for data transmission. So the USB cable wire shield with two wires for power, red and black are for the power, and the other two wires are for the data transmission. White and green are for data transmission, red and black are for power. Now the USB cable, let's say so this is a little detail of the USB. Their speeds are mentioned, and there are different types of them that are for the high speed transmission and for the so this is why so these are the different types of USB cables that are used. Working of USB, its working is plug and play. You just fix it and you start working with it. USB transfer data bit by bit over it is a serial transmission polling mechanism. The host device controls data flow periodically, checking connected devices. Power delivery, USB also supplies power. You do charging via USB cables. Features of USB: hot swappable. Swappable means devices can be connected or removed without restarting the system. This is called hot swappable. If we can remove and connect the device without restarting the system. Some devices require a restart to connect to a computer. So high speed data transfer, and this supports multiple devices via hubs, and standardizes connector types: USB A, B, C, micro USB. Application of USB: connecting peripherals, data transfer between computers and external storage, flash drives, and charging and power supply for mobile devices, audio and video transmission, USB speakers, webcams. These they are basically applications of USB. Steps in USB device detection. This is important. How USB devices are detected. The computer detects the presence of a device due to a change in voltage on the data signal wires in the USB cable. Basically, when you put the USB cable in the USB port, what happens? Voltage is changed, and next, then the device is automatically recognized by the computer. If the computer has the device driver software installed, it is loaded to enable communication between the device and the computer. New device handling. If the device is new and no driver is available, the computer searches for the appropriate driver, prompts the user to download the necessary driver, and in some systems this process is automated, where the computer connects to the USB device and downloads the driver and seeks the user permission to install it. That's it for this part, and we will do our next lecture. Thank you.